Hello, my name is Hai Tai. I am the current president of the ISA Safety Commission. I'm going to have a quick talk about the gear standards, just a little update and maybe the status of the standards as they currently are. For anybody that doesn't know, the ISA gear standards are a set of standards and certifications for slackline, highline specific gear. Let's dig into it. We'll talk quickly about some new certified gear and potential gear that's coming in the pipeline to be certified. Updates to our standards from this past year, potential standards and future work on standards, and then ideas for expansion. This past year, we had a new certified connector, Slacktivity Kingpin. This is from a new standard for highline connectors. So this was the first piece of gear in the highline connector to be certified as a highline connector. We're waiting for quite a few webbings to be completely certified from RAID, but this will represent quite an increase to the number of certified webbings available to the community. In the pipeline, we have potentially quite a few items from North American slackline company, Balance Community, getting certified. So this likely includes webbing and hardware as well, and probably a web lock. Some updates that have happened in this past year. Maybe I'll talk about updates generally. 2023 was a big year for changes in our highline system and highline webbing standards. In 2023 last year, we made a big push to add fractionated highline systems, so connections in webbing, and also dedicated backups. This represented quite a change to the standard. This past year, the standards in general have been much more stable. So the highline system, now we added anchor access system to the highline system. So this is just a definition of ways to get to the anchor safely as part of the safe highline system. The big change this year has been new lifetime recommendations, which came as a result of the CRG incident. Previously, I think we have it on this page. Previously, we had recommendations for ultra low stretch webbings made of Dyneema, and then other recommendations, and also recommendations for other high-tech webbings. Given that the accident that has happened with likely due to advanced weathering or weathering, we basically do not have enough information to have a recommendation. So we've removed our recommendation for Dyneema webbings, and then also other high-tech webbings we don't have quite enough information for to have any kind of lifetime recommendation. The manufacturer, of course, can give recommendations for their individual webbings. We are hoping to conduct tests on Dyneema webbings for UV exposure and weathering. Once we have more information, then we can potentially have recommendation in moving forward into the future with regards to lifetime. I think we have also shortened our lifetime recommendations for polyester and polyamide. We made some small changes to that as well. Let's see. So new standards, new changes. So the ISA sling standard, the highline sling standard, was finished last year. I think potentially this year we might have certified slings coming. Once that's done, we'll have Highline systems that can be certified end-to-end, basically. Updates for the Highline connector, as I said before, the Slacktivity Kingpin is their first product that's been certified. I think, yeah. Okay, in dev, we have trick-line system standard, defining everything in a trick-line system. That's still under active development. The status of the starter kit standard never really got off the ground because of DIN. I don't think we'll be putting too much work in it in this coming year. And as I stated before, we need more data for lifetime recommendations on high-tech webbings. Some thoughts and goals. We had previously a goal to get leashes from all manufacturers, all major manufacturers certified. That's still a goal. I think if we can get a bit more manpower, human power in the SafeCom this year, we can really push to get that goal done. I think it's a pretty reasonable goal, and it's certainly one of the most apparent things that a highliner will tie into, of course. Our other goal would be to get more certified gear across all continents. Right now, it's mostly Europe that has certified gear. In the Americas, might soon have webbing and maybe hardware from North America getting certified. It'd be nice to find labs in South America to help facilitate this goal as well. And of course, if we have more SafeCom members, we can get more work done with regards to these standards. Okay, here's some links and resources. That is the quick update. I'll open up the chat for questions.
Hello. No, it's not over argument. We are trying to certify some few products, but the fact that we do not certify all of our products is just cost related. That's all. Because in our company at least, but I guess for most of the Slackline companies the same. The cost, the sustainability of our business is really sensitive to the cost prices, and we just selected some few products that are really important, in our opinion, to get certified, to get some extra credibility and some extra safety to offer to the customer. But yes, we weren't able, when doing the sustainability calculation, to certify all of our gear. That's all. I hope in the future maybe it will be possible, but not yet. Another point is maybe I am wrong, but I feel that compared to a standard like we have on climbing gear or whatever, there is a question of responsibility in case of a juridic responsibility that is covered by the standard. The laboratory or the organism that is validating the standard is taking in charge the juridic responsibility in case of an accident or incident on a gear. With the ISA, the juridic responsibility is not taken in charge from the manufacturer, so the manufacturer still have this responsibility, and I think this can be a very big argument to get some more products certified if we can just release the responsibility to ISI. I'm not meaning that I just want to wash my hands with that, but it's something that can be considered.
I'd like to add some thoughts to the first point, the point of cost. If we can find in the near future an agreement among all manufacturers and resellers to agree that everyone certifies their gear, then every manufacturer bears these costs. Every manufacturer has to calculate these costs in the prices of their products, and we have a level playing field. What we have right now is that some manufacturers opt in to certify their gear. They bear these costs, so they have to sell their gear more expensive, and other manufacturers opt to sell their gear cheaper because they don't certify it. This is not a level playing field.
I know, but still it's a label and not a standard. Yeah, I think I have bad news for you. The liability system within the EU, I don't know in Switzerland, is that if the customer has a damage, that's a product liability system. I'm not a legal person, but I had a case where the customer could choose whom to sue. The whole line between the person who brings it into Inverkehr bringen, into
To the market.
brings it to the market. That's a beginner, and then the whole line, import, export, and so on, can be sued. So I think you cannot just let somebody make the certification and this body has a liability, as I know, because we had a legal case in the Ropskos industry. Can you, I didn't understand. Can you rephrase it? So you cannot give me the legal load. Yeah. Okay. Period.
Because they can choose.
They can choose you or me. But mostly you. Can choose. Is it
According to EU law.
Yes, I guess when we pay for the UEA label or I don't remember, but the EN, yes, I am giving the responsibility to the laboratory.
Maybe you can add Philip to this, because
Yes.
I think he has a lot to say about this.
Yeah. Okay. Maybe you can share your thoughts on the whole league. I know that we're not legal experts and we're going into the territory which is never going well because it's very broad. But maybe first clear, you are in the commission, and the question that came up from one of the SlackX manufacturers was once he tests with one of our independent laboratories after our standards, where does the legal responsibility fall? It's a very general question. It's not that easy to answer, but maybe first payment and maybe people can give us some insights on this question.
Yeah, so there is no legal responsibility for the product by any test facility, laboratory, or notified body. And the manufacturers also normally has the legal responsibility for their products. That's in the PPE regulation for European climbing products, for example, and also the general product directive that will be relevant for slacklining products within Europe. The responsibility is always on the manufacturer and to some extent to the importer and so on, but not on the laboratory. Of course, if the laboratory does something incorrect, but that's another type of responsibility. That's not a single product responsibility.
Yeah, and just to add, so yeah, it's on the manufacturer, as first said, and in the case of the UIAA, recently our insurance wanted to increase our cost like in a crazy way, because they were thinking that we are kind of responsible if there is that we would be attacked if there is a problem. But yeah, in the end, it's really the manufacturer who bears it.
Okay, it seems like there could also be a legal safety if a manufacturer can do their due diligence. Sure, they can still be sued, but they can show through the standard that they have tried to independently certify to. Talking about costs, we are very aware of the financial load of these tests. I think in creating the standards, we try and make it so that the independent testing is thorough and relatively easy to do for a lab to reduce the costs of these standards, while still covering everything that needs to be covered. With that in mind, I think like the ISA really has no ability to levy fines against manufacturers or anything of this sort. So like in terms of ways we could enforce uh, applying the standards to all gears or having all manufacturers certify their gear, there's no real enforcement mechanism. So rather than any kind of levying of fines or anything like that, we could potentially make it more beneficial for manufacturers to levy gear. This can be forms of outreach, uh, using the ISA's social media potentially to highlight gear. This is something that to highlight certified gear in particular. This is something that the Safety Commission has been considering for a while, just to increase uptake of standardized gear or certified gear. But up till now, not something that we've really decided to put effort into. Yep.
Thanks, Highlight. Yes, it's a very sensitive subject. I just wanted to make it clear about the legal responsibility. I was talking about it because as a manufacturer, we are paying a lot of insurance about to be covered in case of accident. And in the past, because nowadays I'm not the one dealing with the insurance, but when I was dealing with the insurance for SlackX, I knew that I was a lot, and there were my how to say insurance partner said, and many of us said to me, if there is a standard, at those ages nothing was existing, even the ISA one. But if there is a standard, it would have been easier for us and cheaper to certify than without the standard. And I know that with the actual ISA certification, it's Eduardo's, another my colleague dealing with that, and he said it's still the same, that he cannot negotiate any discount, let's say like that, on the insurance thanks to the standard. And that would help us, for example, to compensate the extra price we are paying to get our product certified.
Hi, thanks for your hello. Hi, thanks for your input for pushing forward products that are certified. What we see right now is that in certain Highline communities, this doesn't matter at all. What we see is that in certain communities, people opt to choose cheaper webbing over safer webbing and over certified webbing, especially. So what we see is that if we have webbings that come with kind of similar specs, certain communities just choose the cheapest they can get, even knowingly choosing weaker webbing and knowingly choosing webbings where they definitely know that the sewings might not be perfect. They save about 20 cents per meter, and they definitely go for the 20 cents knowing that they buy the worst product.
I think that we also have like huge progress to make on this. Probably you and like people that are aware, and in Europe they buy UIA certified, but we have more and more non-certified product or fake certified product on the Asian market, and I suppose that many people buy it on Temu, AliExpress, or website like that. especially like new climbers that just want a cheap thing. So on our side, I think we also have to work a lot on it. We plan to work also directly with the stores online and also shops to train their, so in the physical shop, to train their sellers about the safety label, because there are also a way of communicating about it. There are direct contact with the customers, but also on online shop, like big outdoor shop, because many people buy it through these channels. But yeah, we try to communicate for the moment, but we are far from making enough people aware of what's doing the safety commission and all the safety labels. I think, I don't know, Per, what you think about it, but
Yeah, it's hard for us as well, because the UA safety label is a voluntarily label across the world, and there is big discrepancies in how often it's being used, and also big discrepancies and differences between type of product. So like for dynamic ropes, it's very, very common for the manufacturers to use the safety label, but for some other products, it's not as common. And so one manufacturer might have all their climbing ropes certified, but maybe almost none of some other product, maybe a harness or whatever. So big differences. But then, so the UA safety label has been around since 1960, so we have some history to it. But when it comes to the Europe market, then we also have the PPE regulation for all climbing products, which is of course mandatory because it's legislation that's with the CE mark as proof for compliance. And to some extent that helps because the standards are the same, more or less, the UIS safety label standards and the SEN standards. So I don't know how it would look on the European market if we wouldn't have the European legislation on PP.
Right. It seems like there's some way to enforce in Europe, basically, through the PPE legislation.
Yeah, not just some way. There is authorities in every country that are obliged to seek up and do this type of job to find wrongly marked products or non-marked products or incorrect products. And there is e-taxable way to report incorrect products. But that's for the CE mark for PP, so that doesn't apply to non-PP products. Yeah. So we can't enforce UA safety label. We can just inform that it's a good thing to have, but it's a totally different thing for personal protective equipment.
Yeah, maybe we should wrap this up so we can get to the next conversation, but I will say that just generally, both slackline manufacturers and slackliners themselves are fairly price sensitive. So the cost of the certification is a big factor. However, I think if we could get a foot in the door with every single manufacturer in maybe the form of a leash, which is a relatively inexpensive certification, is also an item which doesn't change very much as opposed to maybe like webbings and weblocks. Leashes generally stay pretty much the same. If we can get leashes certified by each manufacturer, I think that would be a step in getting more gear certified by all manufacturers. Any last comments?
yeah, just on for the safety label to kind of encourage manufacturer to certify more product. We change our pricing, so now they don't pay for each label, but kind of for a batch of new labels. So we hope this measure will help to go for more and more products.
Yeah, we have also considered
how much
ways
effort
to.
would it be for the consortium of ISA and the manufacturers that are already involved in ISA certifications to make these standards CE standard?
Maybe Per or Philip can talk about it. I've never.
Can you go again, please?
I think my
What's
question.
Sorry,
I think
what's
my
the effort
question is,
to take the
the only
standards to
enforceable
CE?
way, from what I recognize right now, would be to transfer the ISA standards into a CE/EN standard, right? So the question that I have is, how much effort would this be to transfer the current ISA standards into an enforceable standard?
A standard is not mandatory within European Union, so it's always the legislation that's mandatory. And without making this a long talk about different types of legislation and so on, and going into the kind of sensitive subject in which if slackline systems are PP or not. So if they are PP, then like climbing products, then it's not the standard that is mandatory, it's the regulation and actual legislation that are written, and it's already mandatory in that case, and then all of your products are illegal at the point. If it's not PP, then it's just the general product directive that applies, and that already applies. The general product directive is just about to be changed to the general product regulation. You can have standards under that, but those standards are not mandatory. But if you want to go down that road and try to develop standards within CEN, then you first need to define a little bit under what technical committee that will be. There will be sporting goods of some sort, so TC 136. So what you need to do is become members of your national standardization organizations, and then the national organization within this TC 136 will vote on if they want to start to work with slackline standards. And you can just hope that you get through that vote, otherwise your membership is not worth anything. And if then you get a vote to start the work on a CEN standard, then the standard is developed in a democratic process, but then it goes to vote, and then it might be published. So you can't just say that you want to get the ISA standards into CEN standards, because it's a democratic process that anyone can be part of that. So even if you have your will on how the standard is going to look when it's finished, and there is a lot of other people around Europe that will be part of the work, and the standard might end up being something that you from ISA doesn't like. That's, yeah, because it's no longer your standard. But firstly, become members of your national standard organization, and through that you can get information how to develop standard within sporting goods.
So we're continuing with the last presentation from the ISA safety event. This is gonna be a presentation by Joshua Leopolz, and it's gonna be on a new brake test machine which we developed here in Bern.
I think we just didn't even do like a handful of tests yet with it, or breaking things with it. So I want to present you what the thoughts are, why we choose the system, what's special about it, and yes, I think we are like in the process for almost 2 years now already that we want to have a brake test machine. I was talking with Tom how we could do it and so on, and there are like different options. So the first straightforward option was to get something like quite similar to Walter-Siebert test, like a hydraulic pump and the hydraulic cylinder. We are thinking about it. I was looking around, and then actually I got a course like electromechanical cylinders. So there's like no oil involved besides lubrication. And I was doing a bit more research, talking to a lot of companies, manufacturers, if this could work in our case. And I was then in contact with one manufacturer and said like, okay, that should work for brake testing also, with like some limitations, or like you need to pay a bit of special care about certain things. The setup we have here is we have electric motor, which is being controlled by like a frequency converter on the bottom. Quite small device, but also quite expensive compared to the motor. And with this, we can control the motor running forwards, backwards at different speeds. Everything is running on 400 volts, so like not like a normal socket, but like strong current, high voltage. And then the other part, the motor is connected to like the mechanical gearbox, which is running the cylinder in and out. So it's like basically a threaded bar, which is getting pushed in and out. Here in the front, we have connected a sledge to like a rail, because the one thing issue with like the cylinder is it needs to be perfectly being aligned. If any side forces are coming on, it can destroy like the bearings inside of the gearbox and destroys the machine. So that's like the special care we need to take. It's like perfectly in line. The whole machine is like put on 2 points, so it's like able to move in this direction relatively freely. So that's like covered, even if we are like perfectly aligned. It's if there's anything happening in this direction, there's no side forces on the shaft. The other directions, like up and down, you need to take a special care, and therefore we have like the sledge attached to this track, which keeps it like perfectly in the center, so there's nothing happening pulling sideways. Then we have like here a big screw attached, where we can attach like a medium-sized shackle, where we can then our device on it. On the other side, we have our load cell, which is also attached to a shackle to like similar structure on the other side, which is like just a fixed point. Yeah. Then on the back side, we have our frames. It's like 2 H-beams above each other, which are attached to the wall. Since everything is fixed to the wall, so we could take off like everything below, can everything go out, and it's just like hanging fixed on the wall, attached with like some big glue-in bolts to it. Yeah, that's the main thing of like structure. We have like a bit of support of the motor, just that it's like it should be fine of hanging like freely off, but we don't want to have like high leverage forces on the wall, so we support this motor a little bit. Then one thing to say here is also like we have some safety measurements. So we have like emergency shut off, 3 of them. One is like this line here. If I pull this, I don't want to pull it now, because otherwise the frequency converter is making some loud noises for a while and restarting. If I pull this, it's going off. So if I'm doing any work here and the machine is running and it's like something is getting tracked grabbed like my hair or like my clothes, and it's pulling me somewhere and I don't reach the emergency button anymore, I can everywhere go and just pull this line. The second emergency button is like here on like the control, where I can move the machine. And the third one is behind the computer, basically, that if you're behind the computer, you can have also an emergency button. We have 2 or 3 options how to control it. 2 of them we plan to use. Like one option is like directly at the frequency converter, controlling the machine, but it's like quite not really handy being down there. So we have like this handheld control, which is connected directly to the frequency controller, which means we don't need to have the computer on. And like this, I can have like buttons going in, going out, and then I've got like 2 speeds. So if I press the button a bit deeper, it's going twice the speed. And then I have like a ultra slow speed if it's like just like for the really last bit. So at the moment we have like 4 buttons available, but we're just using 3 buttons with like, and they have like different depths. So it's like 1 and then it's deeper. Sensors, yes. So there was one challenge with this machine. If we are running at a relatively high speed, the machine it takes some time to stop down because there's actually no active brake in there. It's just like if it's breaking down, there will be a current inducted in the motor, which is then cannot go back to the grid because the frequency converter cannot do this. Very big machines can do this, so they can absorb the energy and bring it back to the grid. But for small machines, that is not possible. And like this, we are limited how fast we can brake. We might get like another braking resistor to dissipate this energy, which is being generated. But for now, we don't have it. So it's getting dangerous if we're getting to the end of the machine because it's like insanely strong. It can go up to 20 tons. So if we say go backwards and it's hitting the end of the machine, it's 20 tons pushing into the machine is like destroying itself basically. So the manufacturer says like some limits. So as soon as we are getting like close with this end to this point, 2 centimeters before this, there's like a sensor saying okay, we're at the end, and then we wired it up, or it's like supposed to be wired up. That's like an emergency shut off, so like the machine is getting shut off.
Is this inductive or is this mechanical?
Inductive sensor. And the problem is like if you had high speed, it's still running like for maybe more than 2 centimeters, more like 3 or 4 centimeters. So if you're high speed, we would like crash into it, and I asked the company and said like, even if we're like not having actively force on it, even if it's just like the free running mass going into there, it's anyway able to just clamp up that much that you could not undo it anymore, and it's like basically destroyed.
Can you get the inductive sensors to another place?
That was like the first option, to have like a bit of more safety margin, but that's not possible. We would need to drill like the inductive sensors are like at the end. You see like the 2 sensors here. There's like one in the front and one on the back. They have like the small light on. As soon as you go with the end of the shaft into there, it's like turning off the lights basically, and signalizing that's there. We could have drilled like new holes. The problem if you're drilling new holes, there's like some small metal fibers falling in the back, and it's like ending up on the shaft, and which is like then just like destroying it over time most likely. So it would be really difficult to do this like once it's assembled like this to change the position.
How about getting another sensor?
No, we have other sensors.
So we have so the solution of this whole topic is if you're running it like so the speed we can run is like up to roughly a bit about over 1,000 millimeter per minute. So about a meter per minute we can run the machine. If you're at this speed, we have like 4 or 5 centimeters of braking distance. If you had like a 350 millimeter per minute, which is our normal testing speed, which we also just detected the test right now, we have like about 0.5 centimeter, so 5 millimeters of braking distance. So that's like enough basically to brake safely because you have like the 2 centimeter distance. So what we did now, we just like installed like some 2 more sensors, which you can see is one sensor. The other one is somewhere back here, somewhere here. So if you're getting like 10 centimeter close to the end, we're limiting the maximum speed. So it's almost like I can show it. It's like just taking a little bit of a moment. So I'm running now at 700 millimeters per minute. That's like what we have at the fast speed. We could go faster. It's just like for now we limited like the maximum speed here, and we're getting closer. And I'm still pushing the button, and now it's like slowing down. So we're just limiting like the maximum speed here. And if I would go now further, like this marking is showing like the maximum how far we can go, then the other sensor is getting triggered.
Hopefully.
Which is about 2 centimeter, 1, 2. And now you can see here back there, it's like basically 0.5 centimeter of overlapping. And now I can only go backwards. Once I think I need to reset it. Yes, reset, and now I can go backwards. I think we tried to do this software-wise that it's resetting automatically. I'm not sure anymore why. You need to look at it. So that's how it works. Problem about resetting is once the frequency converter is like restarting, it's like taking a moment, and then it's like being quite loud for one minute until it's being quiet again. So yeah. Otherwise, what we see here is like there's like a polycarbonate plate, which is basically there to protect like this this track. Because if anything is breaking and metal is destroying this aluminium track, we get like maybe some scratches in there, and then it's fucking up the sledge or it's not running nicely anymore. So we have like here this protection shield over it, which hopefully protects it well enough.
What about protecting the screw?
The screw, yes, that's like now the other thing we need to think about it, because right now the screw is like here free, and one annoying part is if you touch it, you have like oily hands.
You can buy some textile or rubber one.
Yeah, we need to see what is like the best option, how to get something above it to not be able to touch it. And I think the more critical part is like anything is going in. Yes, you need to see. But it needs to work in such a way, because this one is going up to 2 centimeters close to here, so it needs to be really small. Yes. If it's like too flexible, I'm afraid that if the textile is getting into here and getting sucked in, then I have big problems. So we need to see exactly what is the best solution. We have like this distance here in the front where it could get folded up. So it's just like one thing we need to do. So it's like not super urgent, but like medium terms, we want to have like a protection over it. Yeah. Otherwise, one more thing we have is a vacuum cleaner back here, which because we heard from some experiences that there is like a lot of dust inside the ropes, especially if you're testing old climbing ropes. If you look at them, they're sometimes quite early black, which means there's like a lot of metal dust in these ropes, and if you destroy them, then they start like, especially the aluminum, which is dangerous, is flying around. And if you do a lot of tests all your life long, you breathe in this aluminum dust, that's like really not healthy. And so our idea is having like a asbestos vacuum cleaner, so with like a really good filter back there, industry grade. And we want to have like a pipe on top of here, which is like then automatically getting activated. That is like just like sucking in all of the dust, or also like all the nylon fibers or all the fibers that they're not flying around and you're getting into your lungs. So that's like the idea, which we need to still implement and see how well is it working. Yes. Any questions at this point?
Practice cycling.
Yes, exactly. Like the modes which we want to use to use this machine. Like I think it was in the live stream or the first test which we did. Or
yes, it was,
maybe
but
not people saw it.
people didn't see it.
It's like basically a normal destructive test. So we have here the 2 whales to test webbing. So it's like a special web lock, which is a really big diverter. So it should not weaken any webbing. And therefore we just like take the webbing and we just press the button, destructive testing, which is like just pulling until it breaks. We have like an upper limit defined. So if you know we want to break a webbing, which is holding 30 kilonewton, we can put it like 40 kilonewton, and if anything is going wrong, basically, and we're ending up at 4 kilonewton, the machine would also stop. It's like a bit of an emergency, that in case anything is catching or something is going wrong, and we know these numbers are way higher than we expect, the machine is stopping also automatically. And I think with the same method, we can also hold at some point, so we can also just go to 20 kilonewton basically, stay there for a while, and go backwards again.
What's the cycle per second or per minute that you can reach with this?
For cyclic loading. Yes. So second test we can do is cyclic loading, and therefore we have like the software which we still need to optimize a little bit to be more precise, because the difficult part about cyclic loading is you cannot just tell the machine go to 6 kilonewton and stop, because as I said, it takes some time to break down, and if you have like 5 millimeter of distance to break down, if you have like a static device like an aluminum carabiner, it will just, the force going up and is breaking there. So if you tell it 6 kilonewton, it starts breaking at 6 kilonewton, but then getting it destroyed. So we need to know when we need to start to break to end up at 6 kilonewton, and that's a little bit of like an optimization problem, which we are about to solve and find like that we have done something which is like working more or less fine, but it's still not precise enough, and sometimes there are some bugs in there. So we need to solve this like software-wise, and and then we can cyclic load it. Therefore, we have also like to increase like the cycling speed, because that's like what we want to do. We don't want to have like a cycle taking 10 seconds. because otherwise if you want to do 100,000 cycles, it takes more than a week. I'm not sure exactly. I think more like 3 weeks or so to get like 100,000 cycles. So that's a bit too long. So we would like to be relatively fast. I think as far as I know, it's like 1 hertz, like cycle per second. You end up like with like for 100,000.
So
I think it's like a bit less than a day, or
yeah. Something around a day.
Yeah, around a day. So that would be our aim, to get like a cyclic loading test of 100,000 cycles within a day, maybe also 2 days or a weekend. What we need to do for this is like reducing the stretch, because the speed of the machine is limited, so we cannot go fast at a certain point. But what we can try to do is like limiting the stretch, so we don't need to go far for a cycle. If we're managing to have, all we need is like 5 millimeter forwards and backwards, we can have like quite a lot of cycles per minute. So if we're getting like really down to 1 cycle per second, is like the question. But it would be nice to go to a cycle for 2 seconds for a cycle or so. Like this, I think we can work efficiently enough, and therefore we need to minimize the stretch. Therefore, we have like a chain.
Sounds like a cow.
Yes, a cowbell. That's the other one. So we would install a chain, 13 millimeters chain, which has like basically no stretch at all, and can then have like our device in there. I think the main aim is like really cycling metal components. It's like the question, like how interesting is like webbing cycling, because so far I didn't hear that this is like really interesting. It's like also there's a limitation. If you do like high cycles in webbing, it starts getting hot and melting, and then you need to anyway reduce like the speed.
And weblocks and Hemorrhages, the abrasion.
Yeah, so there is some potential things, but anyway we cannot go too fast on cyclic loading webbing. So mainly we will weblocks is the most interesting point to test, and I think in the slackliner thing, and maybe also leash rings or something like this, and they have like low stretch, so you should be able to get like quite a high fast speed, because there's almost no stretch in the whole system, so we don't need to move far. And we can, with this machine, we can also move relatively precisely. We can move like super slow and super precise, and like this, we should be fine to hit the numbers relatively correctly.
From the experience that I have with the lab that we work with, we had an issue about 2 or 3 years ago. That's why I asked if the load cell is calibrated. They had an issue that their machine went out of calibration after some time, and they had to recalibrate. And what I learned from them is at this year, that from then on, they have the guy from the company, it's Zwick. They are in Ulm in Germany. I think they have them in their site every 6 months or every 12 months to recalibrate the machine. So what we've seen is when it was not calibrated correctly, the results were off by like 20-ish%. Okay. So this is an important issue that I think must be addressed in a regular frequency.
Yes, I think when I was back in UK, we also get it calibrated, our machine, and there was also like the thing as like we needed to do it once per year to be, I don't know, able to do a certain amount of certain kind of tests. So there's like some calibration which needs to be done if you want to have like tests or results which are like reliable. I don't know what is exactly the plan. I think we have it like really new, so I guess it's calibrated correctly, but I'm not really up to date what is exactly the situation with the load cell. And I guess like easy solution is also like short term to just put once in a while in a line scale and at least go to 20 kilonewton or something like this, and see if this is like fitting in this range.
The line scale has the same issue. I just send in my line scales like every 6 or 12 months to Andy, because they go off, like if you have regular bangs on them on the side. We had this test in Leopolz with the helicopter tests, and we had 2 line scales that were recalibrated several months before. We had the 2 line scales going different. One showed 5 kilonewton, the other showed 6.5 or something like this. It went off like way off. So the line scale is not a calibration instrument.
But yeah, I mean, getting like another load cell which you know is calibrated, or however you're doing this, we need to see how we're doing this exactly.
Are you controlling by temperature? Because temperature will have an influence on the load cell.
On the load cell, I think down here we have the advantage that it's like quite constant temperature, even winter and summer. I think it should not make a huge difference here, because there's no direct sunlight. We're like in the basement, so it should stay relatively constant here. So that's like, I guess, a good advantage. It's not like that we are above summer where it's like heating up like 40 degrees in the summer. Walter?
But the question is, what's the accuracy you need? And what you're talking about temperature, I think it's not really relevant for that what you need. If you want to compare your device with my device and with UIAA, then it has to be accurate.
Yeah.
But plus minus something you have to decide.
Also, what you have to say, the load cell is able to be, configured, calibrated for temperature.
Yeah.
So you can, this load cell is able to do it and produce, depends on which temperature it has to produce the correct results.
0.2 is normal for accuracy.
And like if you do cyclic loading, how long will the spindle like tolerate this? I mean, going back and forth and basically more or less for metal parts the same position.
Yeah.
I was asking the company and they said like overall the spindles are done. They are not made for brake testing at all. It's like basically, yeah, really we are testing this. I was talking to them and I said it should work. They don't see any problem with this. And I was asking them about this, but what they are made for is actually assembling lines where it's going the whole day in and out, in and out, in and out. And also like 1 meter is I think already quite long one. And a lot of situations like not such much distance where they're moving like this heavy loads around. So it's like not something special that this spindle is going in and out the whole day with high loads. So they said like they don't see any problem, and then asked them like maybe it makes sense to, if I do a new test, I just slightly change the position that is not running always so they were saying point. And they said yeah, that might make sense, but they were not even like saying like yes, do this for sure. It was just like yeah, you can do this, but they don't see any big problem. What they said, if you're doing a lot of tests, you should run out this at some point like all the way in that like the fat and the lubricant can get distributed like evenly again, and also check if there's still enough lubricant on it or that we need to redo it. But that's like the only thing that this could get moved out of the way at a certain point and dissipate. So it's sometimes good to go all the way in and out again to reset everything. Yes?
And do you know about the play, like in your setup? How much mechanical play do you have? Like, especially if you try to do like cycles, you would need to know either you would need a controller that tries to get rid of this, or you would need to exactly know the play you're dealing with.
I mean, the system we have right now, we don't need to have the precise play, because what our approach was, which was like coding-wise not working 100% efficient now, but we try to solve this. Each cycle, so we are aiming for 6, let's say 2 to 6 kilonewton we're aiming for. Initially we're saying, okay, start at braking at 4.5 kilonewton, that we guess we are arriving at 6 kilonewton. We actually measure this value where we are having like this maximum load, and if we're ending up at 6.5 kilonewton, we know next cycle we are starting braking earlier. We're not braking at like 4.5 kilonewton, but at 4 kilonewton already. We're starting braking.
Yeah, what you're describing is the definition of a controller, but like how do you set it up?
Oh, in software.
Okay,
the software is like
only just
the software is measuring basically like the software is controlling everything. So this handheld device is like I can control without the computer, but the load cell is connected to the computer, and also like the whole testing protocol is like on the computer. So that's like independent, and so the computer needs to run, and the computer's non-stop recalculating and readjusting like the range that we are ending up at this point. So that's like
play doesn't even play a role.
No. Play doesn't matter at all. So there might getting more into the system at some point. I mean, also like the carabiner can start failing or deforming or so. So there will be more play in the system at some point, but the software should adjust it accordingly to still be in the same range. So that's like what we want to do. And it was also like one reason why we go for this system is because it we thought it's already relatively straightforward to do the coding for this. And with Simon, who can do the coding, we have like the possibility to write all the software ourselves. So we are completely independent of any companies. So we can do everything what we want to do. Just our limitations is like the question, but we are not independent on any software from another company, which they give us and saying, okay, that's what you can do. and not more. If we're running in any problems, we have like the full freedom to change the software accordingly to our needs. And I think that's like a really big advantage, because I saw so many softwares where I think like, it would be so nice to just have like this small change, and then you talk to them like, nah, we cannot do this, we cannot do this, we cannot give you the open source thing, and you're there sitting there and like saying, yeah.
So you're basically adjusting your controller for every part that you measure, to make sure that it doesn't like freak out and destroy your cycles.
Yes, I mean each cycle is being controlled basically.
No, but like what I mean is like I have a background in helicopter blade testing, and the thing is like if your blade that you're testing is bigger, you also need to adjust the values your controller is controlling your setup with, because otherwise it might actually like get into like destructive interference and like increase the load you're actually putting on your part in every cycle, and just even destroy the machine. So you need to take pay close attention to how the controller is set up if you do cyclic testing, because if you can't just go with one set of variables for every test, because it depends on the stiffness of the part that you're actually testing.
We had like yesterday like the problem we broke like the one carabiner, which we're not planning to break, because exactly of this problem we like setting up a relatively fast speed test, and then we had like the turning point set not low enough, so we are running and the machine was basically starting to break, but by far not fast enough, so the load was going up and destroying the carabiner really fast. We wanted to cyclic loading, we were just breaking it at 20 kilonewton, because we were not setting it up accordingly. So we need to see, one idea is like, it's really like about the coding, how we're doing this. One idea is like to just get like one time relatively slow running test to see, okay, we're going from 2 to 6 kilonewton really slow, that we are actually really managing to stop in time, and then we have like one like an estimation of like how much is the path, how far is it going, and from there on we can do the first calculations of like where are the turning points most likely, and from there on it should work then for all of the materials independently. But yeah,
it will probably not, but I would just like advise to set like limits, like separate limits. Yes. Whenever like your controller cycle goes above like a certain correction that it wants to apply to your forces, you should immediately stop.
Yes.
Otherwise, you will just end up incapacitated.
I mean, that's definitely something we need to look into it, and we can set up also like all of these limits like by hand right now. So that's the advantage. We can have like the flexibility, and we can learn out of this. I think there's no risk of destroying the machine, because we don't plan to cyclic load something which is going up to 20 tons. So everything which we are cyclic loading in there should break before the machine. So that's what we are planning to do most likely.
There's maybe another option would be if you want to cyclic load the carabiner, you put in the system you put a piece of nylon webbing, which you know is going to stretch more, have more.
I think that's not the. I mean, what we are trying to do is getting all the stretch out of the system, and then adding some stretch again. Then you can just run the test slower. So that's like the same, coming back to the same result. If you're running the normal test at like 300 millimeter per minute, you can just go down to 30 millimeter per minute, and then we are for sure not destroying anything, because you're going so slow.
According to the theory, for metal parts, the frequency doesn't play a role. Like according to Röhler theory, which is like the most important theory on like cyclic loading of metals, the frequency at which you're testing is not important at all. So you can just go slower anyways.
You can go slower. It's not. It just takes more time. So what we want to do is like having like a cycle fast as possible, and that means we need to have like as less stretch as possible and run the machine as fast as possible. So that makes it for us, that the challenge for the machine to, if you want to have like 1 cycle per second, it needs to speed up and slow down to the breaking point in half a second. So we have like really small time there, changing it again and around. And we need to see, that's like, we just need to test now, there's different approaches. We could have like this point that we reach 4 kilonewton and then start braking, or we also can calculate from the first initial pull how much distance needs to be done between 2 and 6 kilonewton. Have like this distance, and then having like calculating, saying okay, 1 for like that many seconds, because we know the speed of the machine. we know the acceleration ramp and the braking ramp, and from there we can calculate in theory how long it needs to run, and we can enter like then the seconds, run for so many seconds and then brake. And like this, I think we can maybe be more precise, and maybe it's like not as affected by like some bugs in the programming and the coding, but that's all like the things we need to figure out, and it should technically be possible. It's just like seeing where are the weak points of the coding and how can we do it as precise as we want. And then the question is also like how precise do we need to be exactly. If you want to aim for 2 to 6 kilonewton, and the upper limit we are staying always in the range between 5 and 7 kilonewton, then most likely it's still like a good result out of there. And yeah, it's like a bit of like the thing. It's like not super precise testing. It's like something we get a good idea what happens over cyclic loading with different materials.